Number 44, climate change. Is the planet getting hotter? Experts look at the temperature in the air and the oceans, the kinds of molecules in the atmosphere, and many other kinds of data to try to determine how the Earth is changing. However, sometimes the same data can lead you to different conclusions because of how the data is represented. This is linking back and connecting to right here where he's saying, facts are stubborn, but statistics are pliable. Pliable meaning that they're flexible or they're movable or can change or can bend. So it's basically saying that, based off of how the data looks, the same group of data, it may lead people to think about the data one way, but then when you present it in a different form or fashion, it may lead you to think about the data in a different way. And that's kind of the concept that we're going to explore here. So we have two different histograms. We have a histogram from 1975, and we also have a histogram from the year 2000. And it's asking us to determine how many cities were measured for the study. Well, first I want to kind of make sense of my histogram. Going across the bottom here, this is referring to temperatures. So the 20 is referring to, a temperature that would be 20 degrees, 40 degrees Fahrenheit, 60 degrees, 80 degrees, and 100. And it looks like each one of these bins, if you look closely, so halfway between 40 and 60 would be 50, right? So each one of these little measurements is going up in increments of 5 degrees. So 40, this would be 45, 50, 55, 60. The next place I'm looking is right here on the y-axis. I'm trying to figure out what does each one of these increments or increases represent. Well, this would be 0, and this line is 5. And I'm going to count how many lines are in between those 2 points. So this is 1, 2, 3, 4, and 5. So I know that each one of these measurements is going up by 1. So another way to think of this on a histogram is its frequency. So it's asking, how many temperatures are between, in this case, it looks like 10 and 20 degrees Fahrenheit, and this one would have a frequency of 1. So I'm going to go ahead and fill out the rest of my frequencies. Cool. I'm going to do that for both graphs. And now I can go ahead and start figuring out how many cities. So I already figured out that, these two are going to be 1. So this one has a frequency of 1, and this one has a frequency of 1. I'm adding those two together. And now I need to add it to however many cities had the temperatures between 50 and 60 degrees Celsius. Well, I'm looking at this line. I'm tracking it over to the y-axis, the frequency side, and this looks like it's going to be 9. And I'm just going to repeat that process. So this line up here, and now I'm looking at, looks like 11. This line here, obviously it's 9. It's the same height as this bin over here. Looking down here, this is 1 below 5, so I know this one must be 4. And I'm going to add it all together. If you have not added it, pause the video. If you have, continue on. You add those numbers together, and you get 35 cities. So now repeat the same process for the year 2000. If you haven't already done it, pause the video. If you have, I'm going to kind of zip through and reveal the answer. Okay, so for the year 2000, I'm adding all of my frequencies together, and lo and behold, the answer is 35 cities. So that's our answer for A. Each histogram has a total of 35 cities. And then letter B, it's asking us to describe the spread and shape of each of the histograms that we've created. And then what measures of central tendency would you use to describe a typical temperature for each year? So it's asking, would you use the mean or would you use the median? And then it says justify. So you'd have to say why. So if you haven't done so yet, this would be the perfect time to pause the video and write down those different characteristics of how you describe shape and spread. And if you've already done so, continue on with the video. And remember, what are those terms that we've used before? Well, we've used words like double-peaked, single-peaked, symmetric, non-symmetric or asymmetrical, uniform, skewed, and outliers. All of those terms were from previous lessons. So I'm looking at 1975 first. I'm noticing, hey, this looks like it has kind of one big central peak. So I would think of this as being single-peaked. If I were to draw a line down the center of this histogram, the right half would definitely not match the left half. Remember, it doesn't have to be exact, but if we're kind of approximating, it looks like there's a big gap here. So that obviously wouldn't be the same thing. So I'm going to say it's non-symmetric. You could also write down asymmetrical. And then lastly, it kind of looks like there could be a possible, looks like these two data points could be outliers. So I'm going to write that down as well. Now for the year 2000, it does look different. Once again, I would say, yeah, this is single peaked. It has one big central peak on there. And if I were to cut a line down the center of it, it does kind of look like the right half would match the left half. Not exactly, but in if I'm approximating or kind of looking at it roughly, I would say, yeah, I would say it's rather symmetrical. And it doesn't appear to have any outliers, so I'm not gonna write that down. And then lastly, it's asking us which would we use, mean or median? So starting out with 1975, since it has these possible outliers, I'm going to say that I want to use the median. And the reason why is because of these outliers. It would pull my average or my mean down, which may not be typical. It would pull it down. So I would use median for that. And then for the year 2000, it looks pretty symmetrical. It's balanced. There are no outliers. So I'd say, hey, the mean is probably the best way to find your typical temperature. However, you could also use the median. The median is pretty well-rounded, meaning you could use it in either, data that has outliers as well as data that is symmetrical and balanced. Okay, that was number 44. Let's move on to 45.